Hello, calculus fans. Let's find the area under the curve y equals 1 over x cubed, above the x-axis, and to the right of the line x equals 2. Well, let's take a look at the picture. So we're looking to compute the area of the green region, and notice that we're saying to the right of the line x equals 2, but we're not giving a rightmost bound on this region. So this green region really extends infinitely far to the right. So the way we'll do it is we'll choose a number b and compute the area under the curve y equals 1 over x cubed above the x-axis between x equals 2 and x equals b. So we'll impose a right bound. All right, here's the picture. So we're trying to compute the area of b. So when we write a of b, then we're saying that the area is of the region between 2 and b. So the area as a function of b is the integral from 2 to b of 1 over x cubed dx. All right, this is an easy problem. This is, when we compute an antiderivative, we'll get negative 1/2 x to the minus 2 evaluated from 2 to b. Now keep in mind in here that we're just thinking of b as some arbitrary right bound on this region. It's a parameter that we're going to use. It represents some number, but we're not going to specify what number it is. Okay, we'll plug in these limits now. And we get this expression, negative 1 over 2b squared plus 1/8. Now, we're going to let that b move off to infinity. So we're going to take this bound here and let it move off to towards infinity, because we don't want to actually have a rightmost bound on this region. And that'll give us the total area, so to speak. The area is going to be the limit of this expression, and so if we take the limit as b goes to infinity, then this portion of it just goes to 0 and we'll be left with 1/8. Now if we put all this together, we're going to have a notation. The notation that we're going to write is an integral from 2 to infinity of 1 over x cubed dx. And in order to evaluate such an integral, what we really need to do is compute a limit. Like this. It's really a limit as b goes to infinity of the integral from 2 to b. Remember, infinity is not a number, so we cannot plug it in. The fundamental theorem of calculus will not allow us to plug in infinity because infinity is not a number. So in the end, once we evaluate this limit and we get 1/8, then we can say that that's what we get for the area. Okay, that's all for now.